All right, what we're looking at with the second day of 5-7 here, we're going to look at sort of like what we just did on the warm-up, where they're going to show you the graph and we have to come up with the system now. Okay, so instead of just one inequality like the warm-up, we're going to see two. But it's the same idea, where we got to look at those lines, we have to get the inequalities based off of that graph, create that system. So we're kind of going the other way. Yesterday we graphed the system. Today we're looking at the graph and coming up with the system. Okay, so we're going to look at a few of those. Just make sure that we're okay on it. Then we're going to look at a word problem, okay, how we can set up a system and create the graph to solve a word problem, and then we're going to be done. Okay, there's not that much to this lesson. So we're going to start by looking at a system. Now, when they show you the systems here today, they're not going to show you two different colors of shade. They're going to show you just one. They're going to show just something like this, where most of it is why I know it's a little dark. Let's see if I can make that a little lighter. A little bit better there. So most of it's going to be white, and then there's one section of the graph that is colored in blue. Okay? That one shaded area, that is the doubly shaded region. That's where our solutions are in there. So what that means for us is where our dashed line is for this one, that means this has to be shaded underneath. It means for our solid line, that needs to be shaded above, if that's where it's going to be doubly shaded, right? I want you to go ahead, I want you to create the system. I want you to create the two inequalities that are shown here. All right, we're going to give me one of those inequalities. What's one of the inequalities here? Oh. Y is greater than or equal to -2. Good. Remember, a horizontal line, we just talked about it. Horizontal line is y is equal to a number. So this is y is equal to -2. Solid line shaded above, so y is greater than or equal to -2. Good. How about the other one? What's the other one going to be here? Ethan? Y is less than x. All right, you got a slope of 1, up 1 over 1. You got an intercept of 0, so we don't have to put either of those on there. We're just looking y and x, and then it's a dashed line shading underneath. Y is less than x. There you go. Good. Questions on that? Okay. Seems like something we can do, right? All right. Good deal. Let's look at. We'll do two at a time here, and then we'll move on to our word problem. Come up with the systems here. Really make sure that you're looking at where does the graph cross a point, right? Where does it cross at a corner of the grid? So go ahead for both of these. Come up with that system. Go ahead, talk to each other about it. Talk to somebody about it, especially that number 6, right? We see something that's maybe slightly different that we haven't seen recently. Okay, talk to each other. People at home, you can type it in the chat, see if you guys agree with each other. All right, for number 6, the one on the left here, raise your hand, give me one of them. What's one inequality that you have here? Riley?
Y is less than x plus 2.
Y is less than, what was it?
X plus 2.
So you're looking at the diagonal one, right? Okay, close, slightly off on that one. What are we missing for that one, Aston? It's gotta be negative x. Because it's going down, it's a negative slope, right? That's down 1 over 1. So it's gotta be a negative or a -1 out front there. Okay, so there's one of them, that's the diagonal one. What do we have for that vertical one? Well, what do you think? X is less than 3. Right, we said a horizontal line was y and a number. A vertical line is x and a number. Okay, a vertical line is x and a number. And then when we have that, we can't talk about up and down, shading above or below. We have to look left or right. That vertical line, that's the only time that we're thinking of it left and right. And so since it's shaded to the left, that's going to be less than. Right? My x values are less than 3. So that's going to be x is less than 3 there. So that would be my system for that. Okay. Good. How about for number 7? Give me one of them for number 7. On?
Y is less than or equal to 2x minus 3.
All right, let's take a look. You're looking at this one, right?
Yeah.
Okay. So we've got an intercept of -3, and our slope is up 2 over 1. Good. Solid line shaded underneath. That's perfect. There's that one. Okay, y is less than or equal to 2x minus 3. Again, solid line, so it's 4 equal to. What about the other one? Cool?
Y is greater than or equal to 1/2 x plus 2.
1/2 x what?
Plus 2.
Let's see. We got a couple things that are off on that one. Right?
Negative 1/2 and then it's 1, not 2.
Negative 1/2 and then across that 1. Right? Across that 1 here. So we got an intercept of 1, and then it's a negative. Again, it's going down that way. So down 1 over 2. Down 1 over 2. So a negative 1/2 x plus 1. Good. So we got to be careful on those negatives, right? We should know just by looking at a line whether it's going to be a positive or a negative slope. We've talked about that before, right? When we first started graphing this stuff, a negative slope is going to go down to the right, positive slope is going to go up to the right. So we should know just by looking at it what type of slope we're going to have. Okay? Good. Pay attention to your shading. Pay attention to solid versus dashed, your intercept, your slope, right? All of that stuff needs to come together to create these systems. Okay. Any questions on that? All right. Good deal. So we got to look at a word problem now. So we're going to look at this word. I can't cut off the picture. The picture is very important. Okay? You gotta have that beach ball in there. So here's our word problem. You have at most 8 hours to spend at the mall and at the beach. So you got 8 hours total. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. How much time can you spend at each location? That's what we're going to look at. So what I want you to do is I want you guys to talk to somebody. I want you to see if you can figure this system out. I will tell you that this system is going to have 3 inequalities. There's going to be 3 inequalities. Okay? Go ahead and try that out. People at home, feel free to talk about it. I'm going to turn the volume down so they won't hear you. You guys can talk to each other about it and see what you think.
No way I'm moving. Okay, so it's not so at least so I think y has to be greater than or equal to 2. So 1 is how about this? You said 3 because x plus y has to be greater than. Wait, no, less than. Wait, it's equals. It can't be more than 8. It has to be less than 8, right? So x has to be greater than 4. Yes.
I think it's that.
No, it's has to be greater than. I put it the other way. 2 hours, 2 hours, at least. At least.
Actually?
I did it!
I'm in love with that. Are you ready?
So there's going to be
This one?
3 inequalities.
Oh,
Okay?
so it's
One is
fancy.
going to
I told you.
One's going to talk about each. One's going to talk about
This
each.
one?
One is just going to be x. And then y is going to have x.
I gave you an idea. I gave you
You got it.
I don't know.
Like each other.
I know. I don't know how to shake my head.
Hey, so the hint for you, and I know some of you guys heard me already. There's got to be 3 inequalities. One is just going to deal with them all. One is just going to deal with the beach, and one's going to deal with the 2 of them together. Okay. Give you another minute or 2 here. See if you can come up with it, and then we'll talk about graphing. If you feel confident in your system and you want to graph it, see what it looks like, then do that. Go ahead and graph it. Graph all 3 on the same coordinate plane.
This is what I'm rolling. The rest of them great. This it's my favorite. I like the reason I said it. I think we have to do one. My friend does life stuff. You got it. Thanks. It just like comes to me. I didn't do it. Oh, oh. Oh, what's that? Oh.
All right, let's talk about it here. So you have to assign x and y to something, right? And even if you use m and b, you still got to know how are we going to graph it, right? So you really got to know which one's going to be your x, which one's going to be your y. Typically, right? Typically, the first one listed we're going to say is x, the second one y. But it doesn't matter as long as you know what you're looking at. So I'm going to say that the mall is x, the mall is x, and the beach is y. And it's important to know which one you're talking about for which. All right, give me an inequality that talks about just the mall. What inequality can we say that just talks about the mall or just talks about x? Right?
2 is less than or equal to x.
2 is less than or equal to x, because we know we want to spend at least 2 hours at the mall. Okay, so my x value, my amount of time at the mall has to be at least 2, and that's what this is. You could have rewritten it as this, same exact thing. All right, x is greater than or equal to 2, either way. Good, so that's talking about the mall. Let's talk about the beach. What do we have for the beach here? Ethan?
Y is greater than 4.
Y is greater than 4. Y is greater than, because we want more than 4 hours. Not more than or equal to, we want more. I don't want just 4 hours, I want 4 hours and 1 minute, right? I gotta have that extra minute in there, I gotta be above 4 hours. Again, you could rewrite it, it could look like that, same thing. Now let's put the 2 together. What do we have for the 2 together?
8 is greater than or equal to x plus y.
8 is greater than or equal to x plus y, and I flip that around, that's x plus y is less than or equal to 8, because the total amount of time we have is 8 hours. So when we add those 2 times together, it could be 8 hours, or it could be anything less than 8 hours. Perfect. So here is our system, and I'm just going to do it this one because the x and the y's are on the left, and we're more used to that. Okay, so there's our system. Any questions on creating that system? Okay, so now let's graph it. So if I go to graph it, we know x and a number, that's a vertical line. So I'm looking at x is greater than or equal to 2. So I'm going to have a vertical line. Notice that I'm only graphing positives. Why am I only graphing positives? Cool.
All the numbers are positive.
Okay, all the numbers are positive. Ethan?
You can't have negative hours.
You can't have negative hours, right? If you think about the situation, a lot of times in word problems, you can't have negative. I can't spend negative 3 hours at the beach. Not a thing, right? That doesn't work. So I'm looking at x is greater than or equal to 2. So I know I'm shading this way. I'm not going to waste my marker, but I'm shading that way. Okay. I've got y is greater than 4. Now y in a number is a horizontal line. So I'm looking at this horizontal line here. It is dashed, and I am shading above. Okay. Good. And then for that last one, if we put that into y equals mx plus b to graph it, y equals mx plus b to graph it, I subtract the x, I get y is less than or equal to negative x plus 8. That gives me an intercept at 8, a negative 1 slope, so I'm going down 1 over 1 the whole time. Okay, all the way down to here, which should make sense because both my intercepts are 8 if you use the cover-up method. It's going to be a solid line. Solid line. And then I am shading underneath, right? Y is less than, so I'm shading underneath that line. So we got to think about where are our solutions. So where are our solutions here? Somebody said it. Is that you? No? Somebody said a shape? In the triangle. It's in the triangle. It's right in here, right? It's this way of the blue, up of the red, down of the brown. This is our solutions right here. These are our solutions. Is that area right there. Okay, so if they ask you for how much time can you spend at each location, that's asking for an example, like a possible answer, right? So if we look at that, possible answer could be 3 and 5. That would work, right? Would it work to have this point right here? No, right? Because it's on a dashed line. It can't be on a dashed line. So it could be anything inside the triangle, or it could be anything on the solid lines here. So like this point would work. This point would work, right? Anything in the middle would work. 2.5 hours, 4.5 hours, that's going to work. Okay? But on the dashed line will not. Good deal. All right. Any questions about that? No? Okay. Give me a second here.